Welcome to the video using the quadratic formula. Hopefully you've seen my previous video on deriving the quadratic formula, but this video is going to cover how to use the formula. So to review, the quadratic formula is a formula that is used to find the real solutions of a quadratic equation when it's written in standard form, noting that a cannot have a value of 0, then it wouldn't be a quadratic function. So here we have x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Noting that our radicand b squared minus 4ac, if it's less than 0, that would result in an imaginary number, so we would not have any real solutions to this quadratic function. Visualizing this, that would mean that the graph had either been vertically translated up, or it's a reflection in the x-axis and vertically translated down, so there's no solutions. So in other words, the parabola will not intersect the x-axis. So there are no x-intercepts, so no solutions. So let's do a practice example. So we have our quadratic function here, x squared minus 10x minus 11 equals 0. And we want to use the quadratic formula to find the solutions to this quadratic function. So the first thing I always do is write down the quadratic formula. So there are many ways for you, but you should memorize it, and I'd always start by writing it down because you can see there's a lot to this and it's easy to forget a negative sign or make an error. The next thing I like to do that I think is a good habit is I note the values. I make sure that this is written in standard form, and I write down the values of a, b, and c. So the coefficients of each of the three terms of our quadratic equation. So now all I have to do is reference this, and I've already made point of noting whether or not there had a positive or negative value. Now I don't need to worry about anything. I just need to substitute in and worry about keeping track of my math and my negative signs. So here we go. We're going to replace b with negative 10. So notice it's negative b. So we have negative and then the value of b, plus or minus the value of b squared, subtract 4, the value of a, multiplied by the value of c, all divided by 2 times the value of a. So now that I have everything in place, I just need to do the math. Negative 10 is positive 10. Negative 10 squared is 100. And negative 4 times 1 is negative 4 times negative 11 is positive 44. So if I find the square root of this, that would be my next step for order of operations. 100 plus 44 is 144, and the square root of that is a perfect square. It is 12. So I have 10 plus or minus 12. So I got that from the square root of 144, all divided by 2. Now I divide it into two equations. I have x equals 10 add 12 divided by 2, and x equals 10 subtract 12, all divided by 2, resulting my two solutions of 11 and negative 1. 10 plus 12 is 22, divided by 2 is 11. 10 subtract 12 is negative 2, divided by 2 is negative 1. So the solutions to this quadratic function are 11 and negative 1. Noting that now that I know what my roots are, I could have solved this by factoring. So the quadratic function will help you discover the roots to any quadratic equation. All right, your turn. I would like you to use the quadratic formula to solve for the roots, the solutions of this equation. Please note, it must be in standard form before you use the values for a, b, and c. So given that hint, go ahead and pause the video, find the solutions, come back and hit play when you're ready to check your work. Welcome back. So the first thing I did was I wrote my quadratic equation in standard form, wrote down the quadratic formula, and I noted the values of a, b, and c. I substituted in my values. I simplified the radicand, and negative 4 is positive 4. Then I have the square root of 16 plus 40 is the square root of 56. 56. which rounds to the nearest tenth of 7.5. So I take that and I write my two equations and simplify. So the solutions are 1.2 and negative 0.4. Let's try another one. Go ahead and pause this video, find the solutions, and come back and hit play when you're ready to check your work. Welcome back. So I wrote down the quadratic formula, the values of A, B, and C. I substituted them in and evaluated. Noting now I have the radicand is 36 subtract 40. That results a value that is negative. So the square root of negative 4, since it's an imaginary number, it's not a real number, we have no real solution to this quadratic function. Your turn. Go ahead and hit pause. Come back and hit play when you're ready to check your work. Welcome back. So again, I wrote down the quadratic formula, the values of A, B, and C, substituted them in, simplified my math, discovering that my radicand is 0. So that's 6 plus or minus the value of 0 is going to give me just one root, which simplifies to 1/3. So that tells me that the vertex of this quadratic function lies on the x-axis. So there's one solution, one x-intercept. All right, let's try a real-world problem. So a ball is shot from a cannon and into the air with a velocity of 40 feet per second. The equation that models the path of the cannonball that has a height of h of the ball at any time t is modeled by height as a function of t equals negative 16t squared plus 40t plus 1.5. What we'd like to know is after how many seconds will the cannonball hit the ground? So if we're talking about our real-world problem, our cannon takes off. We can tell that this is our y-intercept. So we see that it takes off at a height of 1.5, and it's going to go into the air and come back down. So when we do this, this is our x-intercept. So that's the solution. So we want to use our quadratic formula. Value of A is negative 16, value of B, value of C. Plug that in to our quadratic formula, evaluate, and we get two roots, negative 0.04 and 2.5. Because this is a real-world problem, we're going to discard this. This is an extraneous root. It is no pertinence. There's no value to this equation, to the equation, but not to this problem. Okay, so time cannot be negative. So our solution is 2.5 seconds. So after the cannon is shot, it will land back on the ground in 2.5 seconds. So you can see that the quadratic formula will help you solve some of these real-world problems. I hope you enjoyed this video today. Go ahead and subscribe to my channel. If you'd like to see more, give me a thumbs up if you enjoyed the video. Don't forget to check out deriving the quadratic formula if you haven't already.